Okay, let's look at section 8.1, and this is estimating a population mean. And some common problems with population means are, if the population's small, it's very easy to find the population mean. You can use a census and actually compute it. But if it's large, it gets real impractical, real expensive very quickly. And so this is when we actually have to know a sample and take a sample and try to find the sample mean to estimate by. Now, the way to do this is by something called a point estimate. So, look at this table, table 8.1. The U.S. Census Bureau publishes annual price figures for new mobile homes and manufactured housing statistics. The figures are obtained from sampling, not from a census. A simple random sample of 36 new mobile homes yielded the prices in thousands of dollars shown in this table below. Use the data to estimate the population mean. Okay, so if you're trying to estimate the population mean, we've just got to take the mean. So what we want to do is find the sample by using our sample mean formula. So add up all of these sums, all these numbers here, and you should get 2278. Now divide it by 36, and that should give you 6328 for the mean, sample mean. Now realize what this is. Notice it says it's in thousands of dollars. So this is $63,280, like that. $63,280. So that's what we would call this sample mean here, is what we would call the point estimate. And the point estimate just estimates the value of a statistic. So it gives our best guess as to what the population mean is. We know that on average the sample mean equals the population mean, but most of the time it's at least within a little bit of standard error of it. And so because of this, the sample mean is called an unbiased estimator of the population. You really want unbiased estimators because that means it's closer to the actual population mean than not. Okay, if you have an unbiased estimator. All right, so what we have learned is that the sample mean is usually not equal to the population mean. It's off by just a little. We learned that last chapter. We called that sampling error, if you remember. So if you are presenting somebody with a point estimate, it is what it is. It's an estimate. But the people you're presenting to are going to want proof that that estimate is accurate. Well, that's where confidence intervals come in. Confidence intervals are going to be our proof to tell people that it's accurate. So let's look at this problem here. Consider again the problem of estimating the mean of the mobile homes in the data we had previously. Now, keep in mind, we've already solved this problem. We said that the sample mean was 63.28. Okay, let's assume that the population standard deviation is 7.2. Identify the distribution of the variable for size 36. Well, here's what I would do if I were you, and this is going to give you an opportunity to get some practice in where you need it. A normality plot, normal probability plot. Make sure that you know how to do those. We talked about those back a few sections ago. This is the normality plot for that table 8.1. Now remember what we talked about with normality. If it is if our data comes out in virtually a straight line like it has here, we say that we would say that the sample mean, which is what we're looking at here, we would say that the sample mean is a normal distribution. Sample mean is a normal distribution because of that straight line. Now, when we have things that are labeled as normally distributed, that tells us some things. It tells us that our mean of our sample means is equal to the population mean, okay, which in this case is going to be 63.28. Or let's just assume right now, let's assume this is unknown. Let's just say unknown just for the sake of the problem. All right, so 63.28 is our sample of the 36. This is talking about the reason we're going to say unknown is because this 63.28 is just of the sample of 36. Here we're trying to estimate the whole population. Now, the normal distribution tells us that the mean of the sample means is equal to the population mean. It also tells us that the standard deviation of the sample mean is equal to the standard deviation over the square root of the sample size. So for this particular problem, the standard deviation was 7.2 and the population size was 36. So if you punch that out, that's going to tell us that our standard deviation of the sample means is 1.2. 1.2. So keep that in mind. Standard deviation is 1.2. Now let's go back and look at letter B. Use part A to show that 95.44% of all samples of 36 new mobile homes have the property that the interval from x bar minus 2.4 to x bar plus 2.4 contains the mean. So basically what that's saying is we want to prove that. We want to prove that this is true. We want to prove that x bar minus 2.4 to x bar plus 2.4 contains the mean. Okay, well, we can use our standard deviation of our sample mean that we just found to do that. Here's how. Where does this come from? Where does this come from? Well, it actually comes from the 68.26, 95.44, and 99.74 rule. And what it says is that 95.44% of observations are within 2 standard deviations of the mean. Okay, that's what that means. 95.44% of the observations are within 2 standard deviations of the mean. So, we want to know if this is 2 standard deviations, because if it is, then yes, this is true. 95.44% are from x bar minus 2.4 to x bar plus 2.4. Well, how do we do that? Well, 2 standard deviations. Well, what's the standard deviation? So what is 2 times 1.2? Well, it's 2.4. So yes, this is true. The 95.44% of our observations lie within 2 standard deviations. So this confidence interval that we have here would contain 95.44%. That would be true. Excuse me. So, how can we use part B here? How can we use this that we just found out? How can we use that to find the actual confidence interval? How can we use that to find the actual confidence interval? Well, this is the interval, but it's not the actual interval. It's more of a suggested interval because, excuse me, I'm sorry about that, because this is a general one without the sample deviation provided, sample mean provided. Now we found the sample mean. back in our very first thing, we found the sample mean to be this. So we can easily find our confidence interval now. Now that we know that this is true, this is the interval, we can substitute our sample mean in here, just like so. And we will very easily be able to figure out our confidence interval. Okay, so do the math there. And this is going to give you 60.88, 60.88 to 65.68. So this right here, folks, would be our confidence interval for this problem. So what we can say is this: 95.44%. We are 95.44% confident. This is how we would interpret this. We are 95.44% confident that the mean lies in this interval. 95.44% confident that the mean lies in this interval. Okay? Let me say that again. We're 95.44% confident because we proved that this is the right interval up here for 95.44% within 2 standard deviations of the mean. We're 95.44% confident that the mean is in this particular interval. So that's what confidence intervals are all about. Okay? How confident are you that it's in this interval? Okay? How confident are you? And now remember, 60.88, 65.68, those are thousands of dollars. So this would be $60,880 to $65,680. So keep that in mind as you're working this problem, okay? All right, so the confidence interval estimate. A confidence interval is an interval of numbers obtained from a point estimate, okay? Now the confidence level, this is the confidence that we have that the point estimate or the parameter will be in the interval. And the confidence interval estimate is the confidence level and the confidence interval all together. Okay, so this is just a little terminology so that you know when problems are asking you for certain things, you'll be able to figure it out. So I hope that made section 8.1 a little easier for you. Please feel free to ask your instructors any questions if you have them. Have a great day.